Go.
Hello, this is video assessment 2 and I'm solving problem 20 from chapter 2. The problem has two parts to it. The first part is using the step size of 20 seconds, predict where the spacecraft will be after 40 seconds after firing the thrusters. To solve that, before solving, these are all the given information in the problem. These are like the mass of the spacecraft, the initial velocity of the spacecraft, the initial position of the spacecraft, the net force for the 20 seconds time period, which is also given. To solve this problem, first we have to find the initial momentum of the spacecraft. To find that, it is the initial momentum is equal to the mass of the spacecraft times the initial velocity. The mass of the spacecraft and the initial velocity is already given. So I just multiplied them together and I got the initial momentum, which is 0, 30, 0 times 10 to the 8 kilograms meters per second. After I found the initial momentum, I found the final momentum of the spacecraft. So which is the initial momentum plus the final, the net force and the change in time. I forgot the I. So the initial momentum we just found here. So I just plugged it in. The F net, which is already given, F net and the change in time, those both are already given in the question. So by solving that, I got 12 times 10 to the 5th, 30 times 10 to the 8, 0 kilograms meters per second. After solving that, we had to find the velocity of the spacecraft after 20 seconds. To do that, I use this formula. The final velocity is equal to the final momentum over the mass of the spacecraft. The final momentum we just found here, so I just plugged it in, and the mass of the spacecraft is also given. So I just plugged it in, and by solving that, I got 8, 20 times 10 to the 3rd, 0 meters per second. So the velocity, the final velocity we just found is for 20 seconds, after 20 seconds. So after finding the velocity after 20 seconds, we have to find the position of the spacecraft after 20 seconds. To find that, I just use the position update formula, which is the final position is equal to the initial position plus the velocity of the spacecraft after the 20 seconds time period and the change in time. So the initial position is already given, so I just plugged it in. The velocity of the spacecraft after 20 seconds, which we found here, I just plugged it in, and the time step is 20 seconds, change in time. So when I solved that, I got 12.16, 415, 0 times 10 to the 3rd meters. After I found the final position after 20 seconds, I had to find the final positions after for the second time step. So to do that, the final position for the second time step is equal to the final position of the first 20 seconds plus the final velocity of the first 20 seconds we found and the change in time. So the final position we just found here, I just plugged it in. The final velocity we found here, I plugged it in. For change in time will be an extra 20 seconds than what we already found. So it's 20 seconds. So 20 plus 20, it'll be 40 altogether. So when I solve that, so the final position of the spacecraft after altogether 40 seconds will be 12.32, 815, 0 kilometers. So that will be the answer for the part A. For part B, we had to find where would you have been if the thrusters were not fired. So if the thrusters were not fired, we just had to find the new position. So since the thrusters have not been fired, the initial velocity would have been the same all the way through. So there isn't much to do. So I just used the position update formula, which is the initial position plus the initial velocity and change in time. The initial position, which was already given here, and the initial velocity is also given in the problem. And for the change in time now will be 40 seconds altogether. So by solving that, I got 12, 815, 0 kilometers. So that would be the answer for part B. Thank you.